Here we're going to talk further about graphing trig functions. Now there are two main approaches to graphing, and the first is mainly what we're going to use, and it's called the 5-point method. Okay, and it's called that because you pick 5 points to graph your trig function. The second method is using transformations. Now transformations are mainly used when you're graphing sine and cosine. So these are really important in applications like in engineering and physics and so on. So we're like I was saying, we're mainly going to use the 5-point method, but we're also, when it comes to sine and cosine, we're going to view the transformations. Now in both cases, we want to write our function. Let's say you had sine in the following way. Y equals A times sine of B times x minus c plus d. Okay, the A, B, C, and D are all going to have significance as far as transformations are concerned, and they're going to give us a way of sort of confirming the graph based upon transformations once we have the 5-point method in place. So that's what we're going to do. We're going to start, when we start graphing functions, we're going to try to write the trig functions in this form. Okay. So the main thing about this form, the main thing you have to do is make sure that x is the coefficient here is a 1. So if the coefficient's not a 1, you want to factor that number out. Okay. So now it turns out that you want to be able to have this form, but you also need to be aware of what the basic six trig functions look like, their basic shapes, and the intervals over which we graph them. So let's look at that now before we begin with an example. So first of all, when graphing sine, okay, the basic shape of sine is like so. Okay, and the interval over which you're going to be graphing it is from 0 to 2 pi. The basic graph of cosine is, it starts high and it goes low and it comes back to high again. Okay, and we're going to be graphing that again from 0 to 2 pi. And the basic graph of tangent, well, tangent's got an asymptote on the left, an asymptote on the right, and the basic graph looks like this. And we're going to be graphing that from negative pi over 2 to pi over 2. And then for next one will be cotangent. That has an asymptote on the left, an asymptote on the right, and the basic graph is going to look like this. And that's going to be from 0 to pi. Next one will be secant. And secant has an asymptote on the left, an asymptote on the right, but also an asymptote in the middle. Okay, and then it has this. It's going to have an up cup, what I'm calling like this little up cup, and also this little down cup. Okay, and we're going to be graphing that from negative pi over 2 to 3 pi over 2. So this asymptote's going to be at negative pi over 2, and that one's going to be at 3 pi over 2. And finally, the last function we'll be graphing, the basic shape, which is cosecant, has an asymptote on the left, an asymptote on the right, again an asymptote in the middle, and it's going to look like this as well. Okay, but it's different than secant because we're going to be graphing that from 0 to 2 pi. In other words, the asymptote here is at 0 and this one's at 2 pi. Okay, so you have to memorize these 6 basic shapes, and as importantly, or maybe, well, yeah, as importantly, is the intervals over which we're graphing them. Now it's not too bad because most of them start at 0, right? 1, 2, 3, 4. Those all start at 0, and only one of them, cotangent, has a period of pi. All the others have a period of 2 pi. The other functions, that is tangent and secant, they both start at negative pi over 2. And of course, tangent has a period of pi, so you end at pi over 2, but secant has a period of 2 pi, so it ends at 3 pi over 2. So all the functions either start at 0 or negative pi over 2, and then you have to remember their period. Okay, so armed with this knowledge, let's go ahead and graph a trig function in full glory. Okay, let's graph f of x is equal to 2 minus 3 times sine of x over 2 plus pi over 4. Okay, so we're going to start by writing this in the standard form. So this will be, and let's replace f of x with y. So it's going to be y is equal to, now that negative goes with the 3, so I'll write that first. It's going to be negative 3 sine of, okay, let's first write x over 2 plus pi over 4 plus 2. Okay, all I did is I wrote the plus 2 at the end. Okay, now I see that x, I'm multiplying that by 1/2. So let's write that as y equals negative 3 sine of, okay, factoring out that 1/2, it's going to be 1/2 times what? Well, x, that's why I did it, right? So I could have just x here. And then plus, now what does this have to be? It's not pi over 4 anymore because this 1/2 is distributed because it's multiplication. And when you distribute the 1/2, that means that this has got to be pi over 2. Now, how can you be sure? Well, you can multiply these, right? Because 1/2 times pi over 2 gives pi over 4. That's your check to make sure that you factored this correctly. Okay, so now that it's in this form, now we can make sense, or we can talk about what transformations we see. So first of all, the amplitude. Okay, the amplitude is the absolute value of whatever number is out in front. So the amplitude, let me write AMP so you know it's actually the amplitude. Okay, it's the absolute value of that number. So it's the absolute value of negative 3, which is 3. Okay, so the amplitude is actually the absolute value of A. Okay, and then the period can always be found by, for sine, taking its old period, which is 2 pi, and dividing it by whatever number you have factored out. So in this case, I divide that by 1/2, and I find my period is, well, remember, this is, something divided by a fraction. And when you do that, you multiply by the reciprocal. So the reciprocal of 1/2 is 2, so the period is 4 pi. Okay? And next step would be to talk about a phase shift. And remember the phase shift, we saw a video on this earlier. To think about the phase shift, you have to look at what's inside the parentheses. And you always want to regard this as x take away something. Now, what are we taking away? Well, because it's positive, we're taking away a negative pi over 2. That is, x take away negative pi over 2 will give us x plus pi over 2. So the phase shift, I'm going to write as negative pi over 2. Now, when it's negative, that means the phase shift is to the left. Okay, so the graph is actually shifted to the left. Okay, so once we've identified our transformations, and of course we also have this negative, and that's going to give us a reflection, and then plus 2 means that the whole graph is going to be translated up in the y direction 2 units. So once we've done that, what we then do is we take what's inside the brackets here, and we first set it equal to where we set the basic graph of sine on the previous page, right? Went from 0 to 2 pi. So we first set this equal to the left, which is 0, and then to the right, which is 2 pi. And that's why you had to know not only the basic shapes, but also where the basic shapes started and where the basic shapes ended. Let me go back to that previous page just so you can see that again. So I was talking about this, right? Sine started at 0 and ended at 2 pi. So that means for the graph I'm doing now, I'm going to set this equal to 0 and then to 2 pi. So let's do it. It's going to be 1/2 times x plus pi over 2 is first equal to 0. And then the same thing, 1/2 times x plus pi over 2 is then equal to 2 pi. Let me erase part of this graph so we've got a little more room. Okay, so then what you have to do is you have to solve these equations for x. So do you see how I'm multiplying by 1/2? The left-hand side. So I'm going to multiply both sides of this equation by 2. So let's do it. So multiply the left-hand side by a 2. Okay, and the same thing with the right-hand side. So the left-hand side, the 2's cancel, that's why I did it, and I get x plus pi over 2, and the right-hand side is just 0. And when you do the same thing here on this equation, the 1/2's cancel. go ahead and write that in. So I've got a 2. They cancel, and I've got a 2 over here. The 2 and the 1/2 cancel, and so I've got x plus pi over 2. But here I've got 4 pi. Okay, and now when I solve for x is equal to negative pi over 2. And over here it's going to be, well, x is equal to negative pi over 2 plus 4 pi. Okay, now when we add those together, we get, let's leave this first one, negative pi over 2. And this is, let's see, I need a common denominator, right? So right now it's over 1. So it's going to be x is equal to negative pi over 2, top and bottom by 2, right? So plus, well, it's going to be 8 pi over 2. So x is negative pi over 2. And then x is equal to 7 pi over 2. Now, what's the meaning of these numbers? Remember how earlier we said the basic graph of sine started at 0 and ended at 2 pi? These numbers tell you where the new graph starts and ends. That is, our graph, our function, starts at negative pi over 2 and ends at 7 pi over 2. So this is the beginning and this is the end. Now, we're going to scale the x-axis, right? And it's going to have negative pi over 2 is going to be our beginning and 7 pi over 2 is going to be our end. But you also, once you find the beginning and the end, what you need to figure out is, because we're using the 5 significant point method, what you need to do is you need to find the 5 points on this x-axis, okay? And the way you do that, yeah, you have the beginning and the end, but the way you find the other points is you take the right, that is the end, and you subtract the beginning one, and then you divide by 4, okay? That's going to give you what I call the step size. So this is what I refer to as the step size. And the way you find this is you take the right, like I was saying, 7 pi over 2, and subtract the left, negative pi over 2, and then divide that by 4. So let's see, it's going to be, well, take away a negative, that's 8 pi over 2, which is 4 pi divided by 4. So the step size is going to be pi. Now, that means we're starting at negative pi over 2, and every time we're stepping in pi. But this is, pi over 2, so this has a denominator of 2. It's going to be easy if we make the step size and these have the same denominator. So let's change this to something with a denominator of 2. That's going to be 2 pi over 2. Isn't pi the same as 2 pi over 2? It is. Okay, so here's the strategy. Start at the left, right? Negative pi over 2. So we're scaling the x-axis, right? So this point is negative pi over 2. Okay, and we're going to step in 2 pi over 2 to get to the next significant point along the x-axis. Remember how we need 5 significant points? We're looking for the next one. Well, if I step in this far, that brings me to 0, right? If I step in one more time, that brings me to pi over 2. Now notice that 2 pi over 2, right? I went from here to there. This length is 2 pi over 2. So this is the first significant point right here. This is the second one because the step has been 2 pi over 2. Okay, where would the next one be? Well, you add 2 pi over 2 to this, and that's going to be 3 pi over 2, right? So 3 pi over 2 would be right here. So what I'm doing is I'm saying, okay, this is 1 pi over 2. This is, 2 pi over 2. 3 pi over 2, and 3 pi over 2 is 2 pi over 2 away from pi over 2. Where's the next one? Another 2 pi over 2. That's going to be here, 5 pi over 2, and then finally another 2 pi over 2, and that's 7 pi over 2. Okay, and I'm going to fill these in as well. This right here was 4 pi over 2. This would be 6 pi over 2. So notice how I stepped in. Well, I stepped in once, stepped in again, right? There's my third significant point, my fourth significant point on the x-axis, and then finally my fifth. And if everything went right, you should be ending right here at 7 pi over 2. So you start at the left and step in 4 times, 2, 3, 4, using your step size. And if everything went right, you ended at the correct value of x that you found here. So that's a little bit of confirmation for you. Okay, now that takes care of the x-axis. Now what we have to do is think about the y-axis, okay? Now remember, Let's go back to the previous graph for sine again, so we can see this. Sine, well, this value, the y-coordinate is 0. The y-coordinate is 1, 0, -1, and 0. So you have to know sine's old y-coordinates, right? 0, 1, 0, -1, and 0 at the 5 significant points. So let's go ahead and look at our graph now. So the argument is this. Yeah, it used to be 0 right here, the y-coordinate, right? But now what happens? Well, according to this, right, the output of this whole thing, that's the old y-coordinate. So right here, the y-coordinate used to be, at this point, it used to be 0, as we saw, right? Just from the previous graph, it used to be 0, but now you multiply that 0 by -3, and that's still 0, and you add 2 to it. Oh, that means instead of 0, you actually get 2. So let's go ahead and scale this axis. 1, 2, 3, 4, 5. So instead of 0 right here, you get 2. And this is the first significant point of our graph. Okay, so we're going to have 5 of them. 1 here, 1 somewhere in here, 1 somewhere in here, there, and there. This is the first one. Now think about sine, right? So sine went like this. It started at 0. It went up. So at the next significant point, we used to have 1. So this used to give us 1. Okay, but then you multiply the 1 by -3. That's -3. 1 times -3 is -3. Add that to +2. And instead of 1, now we get -3 plus 2 is -1. So here we get -1. So -1, -2, -3. So here now we get a value of -1 down there. Okay, at the second significant point. Third significant point for sine, we used to get 0 again, right? Well, now it's 0 times -3 plus 2. We get 2 again. Okay? And the next one, we used to get -1. Let me show you what I'm talking about. Right? So I just went through this. I used to 0, 1, 0. I used to get -1 right here. Let's see what I get now. Well, -1 times -3 is +3. Added to 2 is +5. So over here, at this point, I get +5 now for y. So way up here. And then finally, at the next one, you used to get 0, but again, that's the same as these, which is +2. That's what we mean by the 5-point method, is you have to know the 5 x coordinates and the old 5 y coordinates. And then you ask how are those y coordinates transformed by multiplying by this number and adding and subtracting that number. Okay, now you can see what our graph looks like, yeah? It's going to look like this. And you might say, oh, that doesn't look like sine, that looks like upside down sine and shifted over. And I agree with you. It makes sense that it's shifted over -π/2 because we said the phase shift was going to be -π/2. That is a phase shift to the left. That's reflecting the fact that we're moved over horizontally to the left, right? And moreover, it's upside down because of the negative right here. So the negative is a reflection, okay? So let's go ahead and graph that in now. It basically looks like sine, just shifted to the left and upside down. Okay, so there's one cycle of sine, right? We started here, we went down, back up, and we're finished there. Now I drew this, I kind of extended this dotted just so you could see what's going to be happening, right? The wave is going to keep repeating, and same thing in the other direction. It's going to keep going like this, okay? All right, so that's how we handle transformations. Let's try another one now. Okay, let's graph y equals 2 times secant of x plus pi/4. All right, so now this is already in standard form, right? I already have it written the way I want, but the graph is secant. Do you remember what the graph of secant looks like? Well, the key thing is to remember that you're starting at -π/2, the old graph of secant, and it ends at 3π/2. So, and you had asymptotes, right? You had an asymptote here, an asymptote at the end, and an asymptote in the middle. Okay, so what we're going to do is we're going to take what's in parentheses, right? It's already in standard form, and first set it equal to the left. So it's going to be x plus pi/4 is first equal to -π/2, and then set it equal to the right, the old where it used to end. So x plus pi/4 is equal to 3π/2. Now, of course, these have different denominators, right? So let's get these in terms of pi over 4. So x is equal to, well, it's going to be negative 2 pi over 4, right? Minus pi over 4. So I changed this to a common denominator, right? So it's 2 pi over 4, and then I subtracted pi over 4 from both sides. Likewise, for the next one, it's going to be, well, top and bottom by 2 is going to be 6 pi, positive 6 pi over 4, right? Minus pi over 4. And so I've got, let's see, the new graph starts at negative 3 pi over 4 and ends at x equals 5 pi over 4. Okay, and just like before, now we want to find our step size. And the way you do that is you take the right endpoint and you subtract the left, and then you divide by 4. Always. That's what's nice about this method. It seems a little complicated in the beginning, but it really gets easier the more you do it, and it's always the same way. So the step size is going to be equal to 5 pi over 4 minus negative 3 pi over 4, and then divided by 4. So it's going to be, well, 8 pi over 4, right, which is 2 pi in the numerator divided by 4, and that's equal to pi over 2. Now, like I said earlier, you want the step size and the beginning and the end points to all have the same denominator. So let's change this to 2 pi over 4, okay? So the point of doing this is that now it's on the same footing, if you will, as the beginning and the end. And this is our step size. Okay, so you use these numbers to scale, right? So negative 3 pi over 4. So the way I set this up, I'm going to say, okay, well, how about this is negative 1 pi over 4, negative 2 pi over 4, and negative 3 pi over 4. And I'm stepping in, right, 2 pi over 4. And I'm starting here at negative 3 pi over 4. So that would be my first significant point, right, for the x coordinate of it. Step in 2 pi over 4. So each of these is 1 pi over 4. So next one's going to be there. And this would be 0, of course, and this would be pi over 4. And that would be my next x coordinate, right? This will be 2 pi over 4. Let's scale this, 3 pi over 4. 4 pi over 4. And 5 pi over 4. Okay, so where were we? This was our second one. Our third one would be right there. Okay, another 2 pi over 4, right? Brings us to this, 3 pi over 4. Another 2 pi over 4. Ends at 5 pi over 4. And look, we ended where we were supposed to end, right? 5 pi over 4. So to recap, you start at the left and step in 4 times. 1, 2, 3, 4. And that brings you to where you predicted you would end. Okay, now you have to think about what happens at the ends, right? So because this is secant, at 3 of the 5 significant points, that is, at the left, at the middle, and at the right, you have vertical asymptotes. So we've got a vertical asymptote here, a vertical asymptote there, and a vertical asymptote at the end. Let's go ahead and graph those in first. So there are our 3 vertical asymptotes. And now, so this was our first significant point. Here's our second point, right? Now remember what secant used to look like. It was like this, right, in that interval, and it was like that in the other interval. So at this point, it used to be 1. So this, 1, 2, 3, negative 1, negative 2, negative 3. So we used to get 1 right here, the y-coordinate at the second significant point. Now what do we get? Well, just like before, you take the 1 that came out of this, and you multiply it by 2. So instead of 1, we get 2 at the second significant point. So it looks like that. And at this significant point, we used to get negative 1, but now you multiply that by 2, and you get negative 2. So it looks like this. Okay? Now, because this is positive, right, that means the cup is still opening up, right? All the values here are still going to be opening in the positive, are still going to be positive, and all these values are still going to be negative. So there's no negative here that would change the orientation. It's still opening up here and opening down there. Okay, let's draw in those branches for secant now. Okay, so that would be our graph. This would be the upward opening branch, and this would be the downward opening branch. Now, one last point, and it's that if you're thinking about transformations, you might say, wait a minute, this looks like the transformation. You should have a phase shift pi over 4 to the left. And with phase shifts, you have to be really careful when you're not working with sine and cosine. When you're working with secant, you have to remember that the phase shift, negative pi over 4, that is only true for the value that used to be at 0. So in fact, when x was 0, this point used to be shifted over at 0, right? Now it's shifted to the left pi over 4. So you have to be really careful when interpreting phase shifts. And sometimes phase shifts and period changes can interact to trick you when you're not working with sine and cosine. Okay, so this is graphing, and we've been using the 5 significant point method, and that's usually the method that's most reliable. Until next time.